Hello everyone, this is Mr. Ahmad Faidi, Manart Al Language School, and today inshallah we'll start a new video in geometry, and this is the last video in our lessons, and today inshallah we'll talk about general equation of the straight line passing through the point of intersection of two lines. You have studied before how to find the two coordinates of the point of intersection of two non-parallel straight lines. So if you have a1x b1y plus c1 equals 0, this is the equation of first straight line, and we have the second equation a2x plus b2y plus c2 equals 0. It is possible to find the equation of several parallel lines passing through the point of intersection of the previous straight lines. So general equation of the straight line passing through the point of intersection of two given lines. We have the two straight line intersect at the point A, so we can find general equation for all equations that pass through the point A, which is the intersection between the two straight lines L1 and L2. So we have an infinite number of straight lines passing through the point of intersection. The equation which represents all the straight lines passing through the point of intersection of the given line of the given two lines is m by the first equation a1x plus b1y plus c1 plus L multiplied by the second equation, which is a2x plus b2y plus c2 equals 0. So this is the equation or the general equation for all the straight lines that passing through the point of intersection. And M belong to R and L belong to R. So this is the first form, M multiplied by bracket A1x plus B1y plus C1 plus L multiplied bracket A2x plus B2y plus C2 all equal 0, and M belong to R and L belong to R. In this case, if M equals 0, we can get the equation of second line a2x plus b2y plus c2 equals 0, and in this case, in the case of L equals 0, we get the equation of first line, which is a1x plus b1y plus c1 equals 0. If M not equal 0 and we have L not equal 0, we get an equation of the straight line passing through the point of intersection except the original straight lines. In this case, we can write equation in the form. Equation 1 we can write in the form a1x plus b1y plus c1 plus k multiplied by a2x plus b2y plus c2 equal to 0. And we want to find the value of k. Then we substitute by the point of intersection of the two straight lines, so we can get the value of k. Okay, and k belong to R except set of 0. So I have example. Find the equation of straight line passing through the point A, -2 and 4, and the point of intersection of two lines. So we want to find the point of intersection of two lines. We can use the general equation a1x plus b1y plus c1 between bracket plus k multiplied by between bracket a2x plus b2y plus c2 equals 0. This is called general equation, and we can substitute by the first straight line, which is x plus 2y minus 5, then plus k multiplied by second equation to x minus 3y plus 4 equal all equal 0. So to find the value of k, we can substitute by the point -2 and 4. So x equal -2 and y equals 4. So -2 plus 2 times 4 minus 5 plus k multiplied by between bracket 2 times -2 minus 3 times 4 plus 4 all equal 0. So we can find the value of k will be 1 minus 12, k equals 0, so k equal 1 over 12. So replace k and put 1 over 12. and we can multiply all the equation by 12. So x times 12 will be 12x, 2 times 12 will be 24y, negative 5 times 12 will be negative 60, 12 times 1 over 12 will be 1. So write the equation to x minus 3y plus 4 all equal 0. So we can simplify the equation, collect the like terms. So will be 14x plus 21y minus 56 equals 0. So we can divide all equation by 7, will be 2x plus 3y minus 8 equal to 0. So this is the equation of the straight line passing through the point negative 2 and 4 and the intersection point between the two straight line x plus 2y minus 5 equals 0 and the 2x minus 3y plus 4 equal 0. We can use another solution or another method. By solving the two equations to find the point of intersection of the two lines, we can solve the two equations by using calculator simultaneous. So we have x plus 2y minus 5 equals 0 and 2x minus 3y plus 4 equals 0. So we want to find the solution set of the two equations. So we can use calculator or we can solve the two equations simultaneously. So x plus 2y equal 5 and 2x minus 3y equal negative 4. So the solution or the intersection between the two straight lines will be 1 and 2. So the point 1 and 2 is the point of intersection. So we can form the equation by using the 2 points, which is negative 2 and 4, the point A, and the point of intersection 1 and 2 by using the Cartesian form. So we have a rule y minus y1 over x minus x1 equals slope, which is y2 minus y1 over x2 minus x1. So we have the rule y minus 4 over x minus negative 2, which is x plus 2, equal the slope will be 2 minus 4 over 1 minus negative 2, which is 1 plus 2. So y minus 4 over x plus 2 equal negative 2 over negative 2 over 3. So we can make simplify of the equation. So will be 3 times y minus 4 and then negative 2 multiplied by x plus 2. In simplest form will be 3y minus 12 equal negative 2x minus 4. So we'll get the equation 2x plus 3y minus 8 equals 0. This is another method to find the equation of the straight line passing through the point negative 2 and 4 and the intersection point of the two straight lines, which is 1 and 2. We have another example. Prove that the straight line 2x minus 3y minus plus 2x minus 3y plus 4 equals 0 and the straight line are vector equal 1 and 2 plus k multiplied by negative 2 and 3 are intersecting orthogonally, then find their point of intersection. So to prove that they intersect orthogonally, we will get the slope of the first straight line, which is m1, which is negative coefficient of x over coefficient of y, will be negative 2 over negative 3. So will be 2 over 3. And second one, m2 from u vector, we can find the slope 3 over negative 2. So m1 and m2, if we multiply them, then we get negative 1. So the two straight lines intersect and make right angles. So the two straight lines intersect orthogonally. To find the point of intersection of two straight lines, we find the Cartesian equation of the second line. So we have y minus y1 over x minus x1 equal b over a. So y minus 2 over x minus 1 to find the Cartesian, the point of intersection of two straight lines, we find the Cartesian equation of the second one. So will be y minus 2 over x minus 1 equal b over a, which is 3 over negative 2. So simplify negative 2 times y minus 2 and 3 multiply x minus 1. So negative 2y plus 4 equals 3x minus 3. So we have 3x plus 2y minus 7 equal 0. So this is the second equation in Cartesian form. So we have the two two equations, 2x minus 3y plus 4 equals 0, the first one, and second one, 3x plus 2y minus 7 equal to 0. So we can solve the two equations simultaneously, so we can get the intersection point will be x equal 1 and y equal 2. We can use calculator. Then the point of intersection of the two orthogonal straight lines is 1 and 2. Check your understanding. We have two straight line L1, 3x plus 2y minus 7 equal to 0, and we have second equation r equal -2 and 0 plus k multiplied by 3 and 2. So number one, find the Cartesian equation of the line L2. So we have form y minus y1 over x minus x1 equals b over a. So if we use this form, so we'll get y minus 0 over x minus -2, so will be x plus 2 equal to over 3. So we can make cross multiplication and we get the final simplifying of the equation will be 3y minus 2x minus 4 or equal to 4. So this is the Cartesian equation of the second straight line L2. The measure of the angle between the two lines L1 and L2. Okay, we can deduce from slope of the first straight line and the second straight line. In number 2, we can find M1 and M2. So we have M1 will be -3 over 2, and we have M2 will be 2 over 3. So M1 times M2 will equal to -1. So the angle or the measure of the angle between the two straight lines will be 90 degrees. So the measure of the angle between the two straight lines will be 90 degrees. Number 3, we want to find the point of intersection of the two straight lines. So the first straight line L1, 3y minus 2x equal to 4. This is number 1. And we have the second straight line 2y plus 3x equal to 7. This is equation number 2. So if we solve the two equations simultaneous, then we get the point of intersection is 1 and 2. Then the point of intersection will be 1 and 2. And number 4, we want to find the equation of line passing through the point of intersection of the two straight line and the point 3 and 4. So we have 2 points 3 and 4, and we have the point of intersection. The point of intersection is 1 and 2, and we have another point which is 3 and 4. So we want to find the point of intersection, and we want to find the equation of straight line passing through the point of intersection and the point 3 and 4. So we can use this form y minus y1 over x minus x1 equal the slope which is y2 minus y1 over x2 minus x1. So y minus y1, which is y minus 2, and x minus x1, which is x minus 1, equal to the slope which is 2 minus 4 over 1 minus 3. 2 minus 4 over 1 minus 3. So we can get y minus 2 over x minus 1 will equal to 1. Then y minus 2 equal to x minus 1. So we can get x with y, so will be y minus x equal -1 plus 2. So the simplest form will be y minus x equal to 1. So this is the equation of the straight line passing through the points 3 and 4 and the point of intersection 1 and 2. And in number 5, the length of the perpendicular drawn from the point of intersection of the two lines to the straight line whose equation 3x minus 4y minus 9 equals 0. So we have the point of intersection which is 1 and 2, and we want to find the length of perpendicular from this point to the straight line which is 3x minus 4y minus 9 equals 0. So we have a rule, the length of perpendicular L equal to absolute value A times x1 plus B times y1 plus C all over root A power 2 plus B power 2. So absolute value A times x1 will be, we have A equals 3 and B equal negative 4 and C equal negative 9. So, and we have x1 will be 1 and y1 will be 2. So we have A times x1, which is 3 times 1, plus negative 4 plus negative 4 times y1, which is 2, plus c, which is negative 9, over, we have root a power 2 plus b power 2, which is 3 power 2, which is 9, plus b power 2, which is 16. So the final answer will be 14 over 5, which is equal to 2.8 length units. This is number 5, the length of perpendicular from point to a given straight line. Number 6, we want to find area of triangle determined by the two lines L1 and L2 and the x-axis. So we want to find the intersection of L1, which is 2y plus 3x equal to 7. We want to find the intersection with x-axis, point of intersection with x-axis. So we can put y equals 0, so 3x equals 7, so x equals 7 over 3. So y equals 0, x equals 7 over 3. The point of intersection will be 7 over 3 and 0. And to find the intersection of second straight line, 2y minus, the second straight line is 3y minus 2x. 3y minus 2x equal to 4. So we want to find intersection with x-axis. So put y equals 0. So x will equal to negative 2. So the point of intersection will be negative 2 and 0. So the length of the perpendicular from the point of intersection of L1 and L2 to the x-axis is 2 units, because the point of intersection is 1 and 2. Point of intersection of L1 and L2, we have the point is 1 and 2. So to find the perpendicular distance from 1 and 2 to the x-axis will be absolute value to 2, so will be 2 units. The perpendicular distance is 2 units from the intersection point. And this is represent the height of the triangle, and we want to find the length of the base of the triangle. So we can use the rule of distance between the 2.7 over 3 and 0 and negative 2 and 0. So the base will equal to square root 7 over 3 minus negative 2, which is plus 2 whole power 2, plus 0 minus 0 whole power 2. So will be 4 and 1 over 3 length units. So the area of triangle will equal half time length of base time height. So will equal half time length of base, which is 4 and 1 over 3, time the length of height, which is 2. So will equal 4 and 1 over 3 square unit. And this is the last example in our video. Thank you for your listening and see you later.